Hi there, it's Jason Gorman here from Codemanship with a relatively short video about refactoring to property-based tests. So a property-based test, as we'll see, is a test that rather than, if you see these example tests I've got here for a square root algorithm where we're asserting hard-coded literal values, what we do instead is we assert general properties of a result so that we can have confidence that it's the correct result. So rather than saying the square root of 1 is 1, for example, we would assert some general property of any square root that number should satisfy, that result should satisfy. Why would we do this? Well, typically we do this because we want to do very extensive, exhaustive testing where we don't actually know what the expected results are going to be in terms of literal values. We don't want to sit down and type out 1,000 tests, 1,000 square roots. Instead, what we say is that this here is a property that all square roots should have. And then we can generate test inputs, very large numbers of test inputs if we like, to get much better test assurance. We would do this not for all of our code, but for code that is critical in some way. For example, code that is part of a very important, very critical feature, and therefore must never fail, or code that is very heavily reused, and therefore if it did fail, a lot of features would fail with it. So for that load-bearing code, we might choose to go further than we've done here and do property-based testing. Now, this example here, we've got 6 tests. These are the tests I used to test drive my implementation for my square root algorithm using the Babylonian method, if you're interested. And those 6 tests are fine. They're giving me a relatively warm, fuzzy feeling, but now I've just been told that this square root algorithm is going to be used in a flight control system. And all of a sudden, these tests aren't giving me quite such a warm, fuzzy feeling. I think I need more tests. Now, I could just sit down and write more tests, but that's going to take me a long time. And if I want to do hundreds of these tests, or maybe even thousands or tens of thousands, to give me the level of warm, fuzzy that I want to get here, then that's not going to be a very good use of my time. So we can do it the smart way. Step 1 is to refactor one of these tests. Let's take the first one into a parameterized test, a test that accepts the test data as parameters. So we're going to do this in a couple of steps. First of all, we're going to create an array of one object. And then in this array, we do for each loop, and we're going to execute our test inside that loop for that one empty object, that dummy object we've got there for now. So that's one little step there. Let's just rerun the test. And we can check here, it's still running that test. The square root of 0 is 0. But now what we want to do is we want to be able to add more test cases to this. So let's start parameterizing it. So we'll pass our number in and our expected root. And then what we're going to do is we're going to unpack it here so we can use this inside our test. So all we're doing is replacing these hard-coded literal values with parameters. There we go. And if we rerun that, exactly the same test as before, but now we're passing the data in. Once we've done this, we can quite easily add new test cases by just adding more objects to our collection here. So we can do 1 and 1. And we can do 4 and 2. Let's just do those for now because I want to rerun my tests and see them pass. All good. We've gained some extra tests here. And look at the names there. The names are now a bit misleading. So let's parameterize the name of the test as well. I think an easy way to do this would be with a template string. So number and root are provided. There you go. Let's rerun them. Read those tests. Okay, now they're reading like real tests now. And these duplicated tests are redundant. So parameterized tests are a great way of removing duplication from test code. So if you've got a bunch of tests that are all different examples of the same rule or behavior, quite a direct way of refactoring that duplication out is to turn it into a parameterized test like this. Now let's add the other test cases. Notice that I'm taking these small steps. So I haven't done this all in one go. I've done a little bit at a time. Let's do the rest of these. And then finally our sixth test is for the decimal. Okay. We run that, we get all of our tests again. And now these other versions of these tests at the bottom here are redundant. So now we just have a single parameterized test. And they mean exactly the same as the original tests. But now we're supporting a lot less test code. And it would be very easy if we wanted to go further. This is one of the great things about parameterized tests, as well as removing duplication, is it's very easy to add new tests. There we go, like that. So we could keep on going for quite a while. And that's fine. But what if we want to do 100 tests? Am I going to sit here and type out all 100 square roots? It's going to take a while. Let's do this the smart way. What we're going to do, instead of hard coding our array of test cases here, is I'm going to generate it. But in order to do that, I also, potentially the way I've done it here, I would also have to generate the expected root, which is probably going to end up with me either writing another square root algorithm, which is hard work, or it's going to end up with my actually sitting down with a calculator and calculating all the square roots to certain decimal places, and then copying and pasting it in. And that sounds like a lot of work. Now I don't want to do that. So what I'm going to do instead is I'm going to generalize my test assertion. So rather than requiring the expected answer, I'm going to ask a question that I would expect to be true, to be satisfied, if this really was the square root of that number. So what I'm doing here is I'm just squaring the square root, and I'm saying that should be equal to the original number. Let's run those tests. Exactly. So this is now what we call a property-based test. Rather than saying the answer should be X, what we're saying is the answer should have this general property if it's the correct answer. For example, a square root, if you square it, should be equal to the original number. And there are all sorts of examples of properties that we could ask about various things. You use your imagination, but this gives me confidence that these really are square roots. What I've done here is I've reversed the computation to see whether it matches the original input. So that's one kind of property that works very well sometimes. So we have a property-based test, so we don't need these hard-coded answers here. What we could do instead is actually generate. So let's do 100 of these. So generate an array, use the keys of that array from 0 to 99. Not array, there we go. Use the keys of that from 0 to 99. So now we're going to do the square root of numbers, all the numbers from 0 to 99. Let's see what happens now. Okay, that's interesting. Because I didn't fix that. We're actually just passing in a number this time. And we don't know the root, so let's get rid of that. Okay, now this is interesting. We've got a bunch of tests failing, about half of them in fact, but they're not far off. There's some floating point shenanigans going on here. So our results are very, very close, but not quite the cigar, as it were. Close but no cigar. Now what we need to do here is decide whether this delta, whether the slight discrepancy is close enough for our purposes. And I think it might be. I think there's a certain level of, a certain margin for error that we can allow. And I'm going to rewrite my test so that we can allow for a certain margin of error in terms of decimal places. Let's make it 10 decimal places. Okay. And now they're all passing. There you go. So there is a property-based test for our square roots. This is a range, but you can probably imagine other ways that we might do it. For example, there's our array. Let's not use the key. Well, we can use the keys each time, but this time what we're going to do instead is we're going to map that onto, there's our number. Let's call it n. And let's do it randomly. Let's do a whole bunch of random numbers times by 1,000, because these random numbers will be like that. Will that work? Interesting. I'm not sure. Do we need the keys either? We might not. Let's see what happens. So there we go. 100 random numbers. Lovely. Now here's the power of property-based parameterized tests. If I thought that 100 tests wasn't giving me quite the warm fuzzy feeling I want, one character difference, say you just add a 0, and now it's 1,000 random numbers. 10,000 random numbers. Once we've opened this door, it becomes possible to buy ourselves quite eye-watering amounts of test coverage, very high levels of assurance for critical code, very, very cheaply. Of course, if we do a lot, if we do 100,000, for example, that's going to take a while to run. So there might be some performance problems that need solving, as there would be with other kinds of slow-running tests like integration and system tests. And I'm not proposing that you do this for all of your logic. Off it goes. It's going to take it a while. It's crunching through. But it might be that you have a suite of these kinds of tests that you run relatively infrequently because maybe they're only testing 5% or 10% of your code, so you only need to run them 10% of the time. Or maybe you run them overnight, or however you do it. You also, with a bit of engineering, a bit of know-how, maybe can parallelize these tests and stick them on the cloud and throw a lot of hardware at them, which I've been doing with clients. So it is possible to buy yourself, say, 100,000 random tests. If you don't believe me, then we just scroll through some of them there. So there you go. That's pretty high test assurance. 100. We've gone from 6 tests to 100,000 in the space of a few minutes. And this is a great way of buying yourselves very high levels of test assurance with very little extra code very cheaply. It just takes a bit of imagination. If you refactor to parameterized tests as a matter of course, if you see duplicated tests and you refactor those to parameterized tests, you have begun to open that door towards turning those into property-based tests. I'm a big fan of these. What it means is that there is a direct route, using tools you already know, like Mocha in this case. There's a direct route from the kind of tests we write when we're doing TDD to the kind of tests we might need if we were writing safety critical code. There is a direct route. You just need to know how to take it. Once you've opened that door, all you have to do is step through it. So there you go. That's how you refactor from ordinary tests to property-based tests. And that's how you open the door to very high levels of test assurance for very critical code. How many tests will depend on how critical. And I hope that's given you some ideas for your code.